Hello everyone. Now today we are going to see some of the problems on the non-concurrent force system. In our previous session we have seen how to calculate resultant and how to locate that resultant for the non-concurrent force system, and for that we just have gone through the concept of moment. Now today we will see one example with the help of which you will get more clear idea about. Suppose this is the problem given, and for this force system we have to locate the resultant. So for location, the steps that we can use, I will first of all list out all those steps. First we will calculate theta for all forces. Second, we resolve all forces along x and y. If any inclined force is there, then we can resolve that force. So resolve all forces, and for resolution we can use x component as f cos of theta, y component as f sin of theta. Third, we are going to calculate summation of all forces in x direction and summation of all forces in y direction. Fourth step, we'll apply calculate resultant is equal to under root of summation of f of y square, and theta is equal to tan inverse of summation of f of y upon summation of f of x. And fifth step we can use to locate the perpendicular distance, and for locate resultant use Varignon's theorem, that is sum of all moments about any fixed point is equal to moment of resultant, that is r into perpendicular distance. And once again, what we can use to calculate moment, always we are going to use formula f into perpendicular distance, and sign convention, clockwise as positive, anti-clockwise as negative. So all these things are required, and all these things we are going to use to solve this problem. So first of all, very fast we'll calculate the theta for all forces. Now if you see in this total force system, all forces either acting along vertical direction or horizontal direction. This 20 Newton horizontally it is acting, 12 Newton it is vertically acting. Only one force is there, 6 Newton, which is inclined at some angle. Okay, its inclination is not given. It means what? First of all, we need to calculate this theta or inclination of this angle. Now here this 15 Newton meter from its unit also, and from the sign convention, as I already told, that wherever you will see this symbol, this means it is nothing but the couple or turning moment. So it is a couple which is given into the system of 20 Newton. So it is, we can count into the sum of all moments, that is 20 Newton meter, 35 Newton meter, all these are the couples. So for solving this problem, first of all we need to find out the angle for the 6 Newton force. Now if I have to calculate this angle, always I told, whenever we have to calculate the angle, just check out in which triangle that angle is what angle can be included. So that angle here can be included into this triangle. So now by using this triangle we can calculate this angle. So for calculating this angle, at least we need any two parameters. That is, if this side is available and this side is available, we can calculate angle theta with respect to x-axis. So now to calculate this theta, that is theta we can calculate here. For this theta we can see opposite side is known and adjacent side is also known. That is, opposite side is 2 meter plus 2 meter. Here it is 2 meter. 2 meter plus 2 meter is theta is, that is opposite side is 4, and adjacent side is 3 plus 2, that is this is the 5 meter. It means what? We can now use here tan of theta where opposite and adjacent sides are known. So opposite is what? 4 divided by 5, so that theta will be equal to tan inverse of 4 upon 5. This is equal to, theta is equal to, we will use tan inverse of 4 on 5, 38.65. This is the inclination. Now all other forces are acting in either vertical direction or in vertical or horizontal direction. Now we will just formulate, either we can formulate table or directly we can write down equation for summation f of x and summation f of y. Now if for initial problems I will be simply tabulating one table. Now in this you can first of all list out all forces. First force, you can take 6 Newton force, and here theta with respect to x axis. Then we can take this 20 Newton force. Then we can take this 12 Newton force. Okay, only 3 forces are there, and later on we will consider the moment. So 6 Newton force is making an angle of 38.65. Then 20 Newton force is making an angle of 0. 12 Newton force is making an angle of 90 degree. It means wherever any force acting along x direction, only x component we should list out. If any force is acting along y direction, only y component we can list out. So that is x component here and y component. X component for this 6 Newton force, that is if we are going to resolve this 6 Newton force, we can resolve at the point of origin. Is 6 cos of 38.65 and 6 sin of 38.65, x component. Now as I earlier said, if force is acting along x direction, only list out its x component, that is nothing but 20 Newton force. So it will not be having any y component. And if force is acting along y direction, likewise this 12 Newton force is here, only list out its y component equal to the magnitude of that force. That is y component here will be 12 and here x component will be 0. Okay, now so this much about is done. Now simply we will calculate summation of f of x and summation of f of y, so that summation of f of x equation will be equal to, either you can write down this equation or from directly here also you can calculate 6 cos of 38.65. Sign convention for 20 Newton force, it is acting along the negative direction, we should assign here minus sign convention. 6 cos of 38.65 plus sign convention, here also it will be plus. Then 12 Newton force is acting along positive axis, so it should be positive only. So here the value for summation f of x we can calculate now. 6 cos of 38 point, and summation of y you can get 15.74. So here we got value for summation f of x and summation f of y. We can calculate its resultant now. 15.31 bracket square plus 15.74 bracket square, and that is equal to under root of 15.31 square plus 15.74 square, 21.95. Theta we can calculate by using tan inverse of summation f of x. This is equal to tan inverse of 74 divided by minus of 15.31. Theta will be equal to minus of 15.74 divided by 15.31, 45.79. So this, from the sign convention of this f of x and f of y, we can predict that this resultant is going to locate on, or the x component resultant will be located on negative x-axis, which is this one, because of its answer, because of its negative answer, that is summation of f of x equal to minus 15.31, and summation of y is along the positive y-axis. It means what, this is nothing but summation of f of y, which is 15.74. So this way our resultant will be located in. Now that we have calculated resultant and we have located that resultant also, and we have just calculated the angle of that resultant. Now to locate that resultant, once again we are going to use the principle of moments, or Varignon's theorem. Now we know the principle of moment is nothing but sum of all moments of all forces about any point is equal to moment of resultant, that is r into perpendicular distance. Now first of all we will calculate this sum of all moments. So to calculate moment, it means we are going to calculate moment because of every force, that is moment because of this 12 Newton force, moment because of this 20 Newton force, moment because of this 6 Newton force. So 3 moments, and in addition we are going to add up all these moments, that is 15 Newton meter, 20 Newton meter, 35 Newton meter, according to their sign convention. So first of all we will calculate moment. Now suppose we are going to calculate moment because of this 12 Newton first. So let's say that moment because of 12 Newton force I am going to consider as M1. Okay. So suppose M1 once again will be equal to force into perpendicular distance of the M1, and the sign conventions we will assign according to this clockwise and anti-clockwise direction. So the moment here I am going to simply draw this diagram at one side, that is point, or the fixed point O is suppose here, and my 12 Newton force is acting somewhere here. Okay, now what I want, the force, it means what, here that force term will equal to 12 Newton. Now here there is no x component, so whenever it is inclined force, then we'll have to consider both of the components and its moment, but here only one component is there, so you'll have to simply consider the moment because of this 12 Newton force only. So for a moment what we need, the force, that is nothing but the 12 Newton multiplied by the force and its perpendicular distance. So earlier, as I explained, to calculate or to find out the perpendicular distance, simply extend this line of action of that force, and after extending this line simply drop perpendicular on this line of action of this force from the fixed point. So from fixed point I am going to drop down perpendicular here. So this is the perpendicular, so I am going to consider this as the link. So perpendicular distance here, so from the diagram we will come to know what is that distance till 12 Newton force. So if this is our 12 Newton force and its line of action I am going to draw this way. So this is the line of action of this 12 Newton force, and till this line of action this is what my perpendicular distance. So this distance I want, and that this distance is nothing but it is 3 meter. So from this diagram I come to know that this perpendicular distance is 3 meter. And according to this, or by the application of this 12 Newton force on this link, where this O point will be fixed point, and because of that this link is going to rotate in this anti-clockwise direction. So that's why sign convention here it will come minus, because anti-clockwise direction we have considered as negative. So be careful about this clockwise or anti-clockwise movement. So perpendicular distance we just have calculated is 3 meter. It means what? First moment we got here as minus 36 Newton meter, because unit of length is in meter and force is in meters. So m1 value we got here. Now same way we can calculate value of m2. Now to calculate this m2, suppose m2 force I'm going to consider here like as moment m2. Now here moment because of, suppose second moment I'm going to take for this 20 Newton force, for 20 Newton. Once again this moment will be equal to force and its perpendicular distance, sign convention. So force is what? Our 20 Newton multiplied by, once again at one side I'm going to draw this fixed point O, and somewhere this is what our 20 Newton force. So according to this diagram, if you see this 20 Newton and this is nothing but our fixed point. So accordingly I have drawn that force and this fixed point. So now once again to find out this perpendicular, what I have to do? First draw line of action of this 20 Newton force. This is the line of action of this 20 Newton force, and on this line of action drop perpendicular from this fixed point. So from this fixed point this perpendicular I can drop this way. It means what? Now this is what my perpendicular distance. So this perpendicular distance you can consider as one link, okay, as we generally used to consider. So this O point is nothing but fixed here also, and because of this 20 Newton force this link will try to rotate in this direction, that is anti-clockwise. So the perpendicular distance, now this perpendicular distance we have to track out from this diagram. So first of all check out. So if this is the force of 20 Newton and its line of action will be here, and on this line of action this is what our perpendicular distance that we have located, and that is 2 meter. It means here in our formula we can simply multiply it by 2 meter, and according to its clockwise or anti-clockwise movement we came to know that it is moving in anti-clockwise direction. So that's why this should be minus, that is equal to minus of 40 Newton meter. It means m2 value also we got here as minus of 40 Newton meter. Now we'll see moment because of the last force. Now see where's that last force? It is nothing but 6 Newton force, and 6 Newton force is acting at the point O only. So I will simply draw that 6 Newton force first of all. That is, this is our point O, and at this point only, this is what the 6 Newton force, okay, and its inclination also we have calculated as, that is this one, 38.65 with respect to x-axis, 38.65. Now to calculate this moment, suppose this is the m3, and what we have said, that is force into perpendicular distance, sign convention we will assign by using this one. Now this is the inclined force. So what I said earlier, whenever it is inclined force we'll have to calculate moment because of its x component, that is 6 cos of 38.65, and moment because of its y component, that is 6 sine of 38.65. So this will be equal to moment because of its x component, moment because of its y component. So because of its x component, that is same formula we will use. Force will be 60 or 6 cos of 38.65. Now earlier I said if I am going to draw the line of action for this force, that line of action is passing through this point O only. It means what? It will not be having any perpendicular distance. It is in the third note, that important points I have listed out at the last session of moments. Okay, so there I listed if any force and its line of action if passing through the fixed point, then moment because of this force will become 0, because it has got 0 perpendicular distance. So here perpendicular distance for this force is 0. It means what? Moment also will become 0. Same way, the line of action of this y component also, it is passing through this point O only. It means what? Even if we are going to calculate moment because of this y component, that is 6 sine of 38.65 multiplied by, here also perpendicular distance will be 0. There is no perpendicular distance. It is actually the collinear distance. So this will be equal to 0. So over and all we can say that M3 or moment because of this 6 Newton will be equal to 0. Okay. So this way we have calculated moment because of all these forces. Now what we are going to use? The final equation, that is by using the Varignon's theorem or principle of moments, sum of all moments about any point, I have considered that point as O, is equal to resultant and its perpendicular distance, whereas this perpendicular distance we are going to find out. So for that, summation of all moments, that is m1 plus m2 plus m3 and the number of moments listed here. Now here the moments listed, that also we'll have to consider, because this is what 15 Newton meter one moment, 20 Newton meter one moment, and also 35 Newton meter one moment. Now we will consider the sign convention according to a rotation. Now this 15 Newton, it is what? Rotating in anti-clockwise direction. So if you see that 15 Newton is rotating in anti-clockwise, 35 is also rotating in anti-clockwise, 20 Newton only rotating in clockwise direction. So anti-clockwise we are going to take negative and clockwise we are going to take positive. So 15 we are going to take negative, minus 35 minus 15 plus 20. This all things we have to consider into sum of all moments. So first of all, the positive sign it is there, with that we'll consider 20 will be positive. This is 20 minus another moment is 15 and 35, minus 15 minus 35 is equal to R we have calculated. What is that magnitude of R we have calculated? So in our first session we have calculated R as 21.95. So this is 21.95 multiplied by its perpendicular distance. So M1 we have calculated. Here the M1 value we know, it is minus 36, M2 minus 40. So minus 36 minus 40. minus 36 minus 40 plus m3 0 plus 20 minus 15 minus 35 is equal to 21.95 multiplied by its perpendicular distance. So from these calculations we'll get perpendicular distance here. That is, I'm going to take this 21.95 into this division. So once again, first of all, we'll calculate all these things. That is minus 36 minus 40 plus 20 minus 15 15 minus 35. Okay, go to this thing, divided by minus 21.95. So divided by minus, not minus, 21 point, we'll get answer here as minus 4.83. Minus 4.83. Minus 4.83 meter. So this is the perpendicular distance that we got here for this resultant. So it means what? When this resultant we are going to locate, that resultant will be located at an angle of whatever angle we have calculated. So suppose from the summation of f of x and summation f of y, we came to know that this is what the resultant. So this resultant we can locate at an angle of minus 45.76. That is this one. With respect to x-axis, this angle is minus and its distance is also minus. It means what? We got this value here for the perpendicular distance. So this is how we have to solve the problems by using this Varignon's theorem or the principle of moments. In later session we are going to see some more complicated type of examples, and I hope now this concept of moment is also clear. So only thing that student should be careful by observing a diagram, simply whatever distances which are not mentioned there, try to calculate the distance by using the right angle triangle, or that might be using any other data. Simply calculate that perpendicular distance and you are done with that problem also. Okay. So till that time, stay tuned up with this channel and we'll be coming back soon with my next lecture. Thank you.